Hi and welcome to Geeks for Geeks. Today we have a very special guest here, Raj, aka Striver. So many a times we have solved numerous number of problems, but when we get to solve the real question, we get we get surprised or we get confused which data structure to choose. So we would have Striver here. Now, Striver needs no introduction, but still, I would introduce him. Striver is a six-star coder and a candidate master, as well as currently he is a software engineer at Google. Now, let me add him. Hi, Striver.
Looks like I was on
Okay.
mute. Absolutely sorry, I was
Yeah,
on mute. Anyways, hi Siddharth. How are you doing?
yeah,
I remember we had a live, I think 6 months
yeah,
back.
yeah,
Yeah,
6 months back. Here we are
good.
again.
Yeah, good to see you. I think you are now a candidate master.
Yeah,
Yeah, congratulations for that. Yeah, good to see you progressing that well. And yeah, hi everyone. Thank you for coming in such a huge number. The numbers are huge. So yeah, we are gonna
yeah.
discuss about how to recognize which data structure. By the way, so that do you find this as a problem? Because I still remember when I was in my college and I used to do a lot of algorithms, DS. So whenever in an interview, also by the way, the discussion is going to be interview centric.
Mm.
So whenever in an interview, when there was a question which was moreover a new one, a question which was not on GFG or somewhere else, whenever there was a question which was new one, uh, did you find it tough to figure out which DS or which algorithm to implement?
Yeah, absolutely. Like, let me tell you one incident. Like, whenever we use that unordered map, let's take a very small example. Like, I started off doing competitive programming and I started using unordered map. Then, during the testing, I used to get TAB. I never used to understand. Then, after few comments, I understood that yes, unordered map has a worse time complexity. Then, fast forward to that, like many times we get to solve a problem. Like, suppose it is a binary cell, so I am not able to figure out which one to use or a
Hmm.
sorting one.
Hmm. Got
Yeah,
it. I think the unordered map happened with me as well in back in my coding days, because unordered map worst case is big O of n, but
yeah.
usually the best case is big of 1. But in code forces, these setters are so smart that they always give a test case such that the worst case will happen and you'll get a TLE and you have to change
And
it to map.
that would
Yes,
happen in system testing or in hacking.
yes. It only happens in hacking or system testing, and then you suddenly go like a -1. Happens every time.
Yeah, not in
Anyways.
test.
So let's discuss about the types of, by the way, before going into the next, how many data structures are there? Can you guys take a guess before moving on to the next slide? How many data structures? Don't move to the next slide. Let people guess. So that wild guess about,
Yeah.
like, if you want to guess, what do you think, how many data structures are there?
Arrays, then
Don't count like
the
that, come on. Don't count like that. Like take a rough guess.
seven or eight.
Okay, interesting. And then we can't count. There's a bunch of them, and there's a lot of them.
Yeah.
Yesterday happened. I did post on LinkedIn about this, my day in Google. About, I'm not sure if you've read that or not. So I wrote
Mhm.
at 6:30 p.m. I used Dijkstra's algorithm to get back to home,
Yeah, yeah.
because there's a
I would
lot of
still remember. Yeah, yeah.
there's a
There
there's
was
a lot.
the there was people questioning that what is this? How is this? How is this? How is the
Yes.
extra used here? How is that used here? I still
Yes.
read that comment.
So my recruiter came in and he commented, don't use Dijkstra, use A star algorithm. And I was like, what is A star algorithm? Like, have you heard about A star algorithm, by the way?
Yeah, I heard it when I was doing a project on that
Oh,
cube solving one.
I did not hear it. I just googled it and I was surprised that, okay, it's a new algorithm that my tech recruiter is teaching me.
I
So
didn't get a
it's
hang of it, to be honest.
So that's the case. Whenever someone says how many data structures are there, you never have a definite answer, because there might be a lot of data structures which we have not discovered yet, and probably going forward in our life we are going to discover. But anyways, something we know for sure is what are the data structures and algorithms that are important for interview centric. So, guys, if I just name them, I think. it can be classified into two. That is what I feel. You can probably have some of them on this side or some of them on that side. Depends on personal preference. This is completely personal. Like for me, I feel easy to semi medium is something like arrays, two pointers, sliding window, hashing, binary search, stack and queues, linked list, bit manipulation, recursion. I think
Yes.
for me this goes under easy to semi medium. For you as well, so that, or
Yeah,
do you feel probably the tougher questions of linked list might go on the medium, tougher questions, but yeah.
tougher questions one.
Yeah,
And then bit manipulation also sometimes.
yeah, bit manipulation, if you consider computer programming, yeah, it's on the tougher
Yeah,
part. But if you talk about interviews, I think they'll ask you something like a power set or find the maximum MSB in big of one, all these kind of questions. So that is why I kept it on easy and semi medium. So going forward,
yeah.
there's this on the medium and hard, there is something like a backtracking, uh greedy algorithm, trees, graphs,
Mm,
dynamic programming, try strings. Which scares you the most?
Grading in comparative programming, especially in code phases.
Okay,
They're
okay.
very hard
Okay,
to guess.
let's see what does the audience have it in mind. Like, if I ask the audience, like, which of the algo or the DS scares you the most? For me, if I'll be bluntly honest, for first, second, third year was dynamic programming. I was scared like hell. I could not get a
Okay.
hang of it. And going forward in fourth year for me, it was tries. Even
Hmm.
after getting placed, I was not sure of tries. I was never ever sure of tries till I made this playlist on tries. I got a hangover of it. Like when I made a playlist of tries because I was preparing for the interviews of Google, that is when I got a hang of tries. Before that, tries was like, it's very tough for me because for the first time when you do tries, it's kind of very tough to understand how a node's working, how is pointers working, because most of us who do computer programming, they don't use pointers that much. They mostly
Yeah.
use all these STLs and all these stuff, so they're not so okay. A lot of people are saying DP, dynamic
For
programming. Okay.
me, for me, still permutation and combination is a fear.
Oh yeah. I think something like a strings is also tough. If you talk about Rabin Cup algorithm, uh, then because getting the intuition of Rabin Cup, not exactly Rabin Cup, there is this another algorithm in strings. So there are a couple of algorithms. There's
KMP
Rabin Cup,
algorithm.
there's KMP algorithm, there's Z algorithm. So KMP
Yes.
and Z algorithms intuitions, explaining that in a class is I still find it tough, because that is why I've still not made a video. I understand myself, but I still feel I won't be able to explain anyone because the intuition is that tough in itself. Even if you go through YouTube or somewhere else, I haven't found a video which explains KMP. Like, okay, they explain partially, but not a video which says me, okay, if I watch this,
This
I
is the
understand
intuition.
this. Yeah, this is the intuition. No one has done that. A lot of people have just gone through the for loops or something like that. Anyways, I think people do agree. DP, KMP, and all these things. I think everyone has these things in common. So let's
People are
start
still
with
waiting for the graph series.
a graph series. I made 12 videos. I just was out on a trip to Prague, Czech Republic. Just came back today morning. I had my office till now, and I'm now having the session. I'll go back and record. I have given the deadline as 7th August. Till 7th August, you'll get all the videos. I'm not promising it tomorrow you'll get two. Next day you'll get three. But till 7th August, you get each of the videos, and so don't worry about that. Anyways,
But still, that intuition part you focus upon is the best one. Is the
I
best
think
part of your explanation.
I, I think intuitions are very important, because a for loop, running over the for loop and doing a dry run is not teaching. As long as you don't have the intuition about behind a problem, like even if you look at my dynamic programming playlist, I focused on having the intuition, because
Yeah.
if you recognize patterns, that is where that is where the main core lies. So let's talk about like arrays is something very basic. So let's leave it. Let's talk about
Okay.
two pointers and sliding window. What do you think? Which question gives you an idea that okay, like what are the keywords that you look in the question to figure out that okay, I probably should think two pointers or sliding window.
A combination of two elements which would sum to a single element. Like we would get a value, we would go from here to lower down that value, or we
Mhm.
would go from here to increase the value.
Okay, okay.
Or for binary search, if we have a range and we want the maximum value or the minimum value, and we have a monotonous kind of thing, then we can say that this kind of we can move forward with that.
So personally, for me, I'll tell you how I think of two pointers. I know one thing: if the array is sorted, or even if I sort it and I don't figure out, like the array does not get distort, like the logic still stays the same. Basically, if I apply the logic on an unsorted array, whatever answer I'm getting on that, even if I sort the array and if I'm still getting the
Mm,
same answer, I get a vibe that
mhm.
okay, this might somewhere lead to this sorting
True.
kind of thing, because two pointers are generically on sorting, where you say okay, something on this, and let's figure out
Yeah.
because the sorting part.
Mm,
So all the summation kind of problems, which has
yeah.
probably you can just figure out, you can just keep an instance of the 2 and you figure out the 3, or you keep an instance of the 3 and you figure out the 4, and it can just keep
Yeah.
on going. So I think two pointers is something which should be related to sorting. So every time you see sorting, or if you see by sorting, you're not distorting the logic. You can think
Mm,
of two pointers. So everyone, I'll not, you can note it down. Sorting can
yeah.
be referred to as two pointing. That is something which you can note down. Okay. And
I would quickly
if
note
you go
that.
back, yeah, if you go sliding window, what do you think of sliding window?
Sliding window, a
Okay.
combination of continuous one. Like from the either from the taking few elements from the first or taking few elements from the back, or either having a set of it.
Okay, so for me, I'll tell you what I look for a sliding window. Like maybe a lot of people might relate. So for me, whenever I see a problem which says kind of longest subarray, most
Yeah,
of the problems you'll see
absolutely.
longest subarray. Yes, because
Yeah,
the moment you see longest subarray, something which has a subarray, because subarray is contiguous. So you kind of move the pointers sliding, so slides,
yeah,
and then you
absolutely.
move this. So probably if you check out problems which has longest substring, subarrays, you can start thinking of something like a sliding window along with hashing or something like that. That is which I'll always say key. Okay, if you're having an idea as subarrays, substrings, most of the part, as Siddharth mentioned, he was correct, contagious. So
Yeah,
since substrings and subarrays are contagious, because you cannot move a window unless until it is contagious. So that is why any problem, if you see longest, largest, shortest, subarray, substring, you should think of sliding window, and then you can apply maps, algorithms like hashing and all these stuffs you can easily do. So the third one is hashing. I think this is a pretty easy one and a standard one. What do you think about
yeah.
hashing?
Whenever I need to remember.
Yes, I also like. I feel hashing is something like, oh, for interviews. I feel there are very very limited questions. Something like finding
Yeah,
duplicates. Whenever you need
yeah,
to figure out something duplicates or something like these, I think hashing. I think most of the people can solve problems related to hashing if they have an idea. So let's not
yeah.
discuss on hashing because I think everyone is pretty much aware of hashing. Let's go into the next part, which I think is very tough, specifically when you start off
Interesting
with
too.
binary search. Yeah, I think it's very tough when you start off with, but once you get used to it, it is the best algorithm. You feel like wow, like
Yeah,
there's
very
nothing,
easy one.
there's nothing better than this. So yeah, we will read comments, guys. Let's have a discussion for 40-45 minutes. Two people are discussing, probably you can take out a lot from it, and after that we will take up your questions. Don't worry about that. Okay. Okay, so binary search. I'll ask the audience to answer in the comments.
Yeah.
So audience, what do you think? When do you figure out that this question is binary search? And so that I'll ask you the same question as well. What is your experience? When do you think, okay, binary search here? Here I apply binary search.
The most simple one that we see in the DA7, that is finding the element.
Okay.
Next one, lower bound. Like we want to know what is the number of elements less than that element or
Mhm.
greater than that element, lower bound and upper bound. And then suppose we have a range and we can cover that range and we know that the answer would lie in between this and we have a way to recover that which one can be the correct one and which one can be the wrong one. We have a way,
Interesting.
like a monotonous one.
Yeah, kind of that was the keyword I was looking for, monotonous, right? It's a
Yeah,
basically a linearly increasing function, a decreasing function, or an increasing or decreasing function. So I'll tell you how I look for binary search for problems. Probably people, for guys watching out, you can definitely note it down. There's one keyword which is very important. Whenever you see a question which states find the minimum or find the maximum, not all the
yeah,
questions, but most of the questions you will see, like if you take an example of book allocation problem, it's something like find a
yeah,
minimum. So whenever you see a question which states, it's not necessary that the array has to be sorted. First of all, for everyone watching out there, Take it out of your mind that binary search means array is sorted. No, array might not be sorted. Just take it out of the mind, because if you keep that in mind that array is sorted, you'll never be able to apply binary search. So binary search is something, whenever you find a question which is like find the minimum answer for this, find the maximum. So most of the problems of tougher binary search are minimum and maximum. You'll actually see this if you solve book allocation. There's this painter's partition, there's this aggressive cows, then there's this a lot of other problems. You will see that. Okay. And the other thing that you have to notice is whenever they're saying you to find an answer, so you will find a pattern that on a particular answer, you are having some value which is higher. And if
Yeah.
you increase the answer, that value goes either higher or lower. And it maintains an order. On an
Yeah.
increasal of answer, the particular value goes down or goes high. So
Yeah.
if you see these kind of things, then you start thinking that okay, this is where binary search is. And I'll always say, you if you want to learn binary search, there's no better question than book allocation and aggressive cows. Understand these two questions in depth. I repeat, if you don't know aggressive cows, it is on sports. I have a video on it. As the other one is book allocation. Do these couple of problems, you will get an idea that the array does not have to be sorted necessarily. And after that, you can just explore all the problems. If you do these two problems, trust me, you'll be able to do most of the problems that are asked in interviews with ease. And the other pattern that I think Siddharth said was the lower bound or upper bound. Basically, whenever there's like number of elements lesser than that. So there is something as lower bound and upper bound in binary search, which is as a C++ STL function. In Java, there is no function as that.
Hmm.
But if you read about the implementation of lower bound, it's wonderful. Even if you read about the implementation of upper bound, it is again very good. So I think these things and these couple of problems, if you do, you have a bare minimum idea about what to expect, and that are the patterns. Just look for the word minimum, maximum. Okay, cool. So let's get into the next one. Stack and queues. Interesting. What do you think? I guess you will not
Hmm.
be able to
Very
answer this.
interesting.
I'm very sure. Tell me, when do you apply a stack?
When I want to see the last element, but the indexing is not the one. Like don't want to see the ith minus one, but I
Uh-huh.
want to see some incidental the last one.
Okay.
This thing hits me a little bit.
Okay. I think stack looks very easy, but when you solve
Looks very
problems,
easy.
it isn't easy because to figure out that,
Highest, most
yes.
difficult.
Yeah, I think it is one of the tougher ones, but it looks very easy. I think someone
Hmm.
did comment monotonic stack. Yes, again, if guys you're noting down, write this down. Monotonic stack, very very important. Just solve problems which are related to monotonic stack, which is basically something as if you have seen next greater element. Again,
Yeah.
try to visualize next greater element. Just do not like memorize the next greater element. Try to understand how it is working. So we don't use stack just for last in first out. That is a very very wrong process of thinking. You might think stack means last in first out. No, stack has a lot more use than that. Easier problems, it's easy to solve problems like balanced
Yeah.
parentheses and these. But when you go into tougher problems, something where you're standing at a point and you need
Yeah.
to know which was the last
The
element that was
last
smaller
one.
than you, which was the
Yeah.
last element that is smaller than you, and you just wanted to know. Or you might be wanting to know which was the last element right before you which was greater than you. So in these kind of problems you should always apply the concept of NGE or NAC. NGE goes as next greater element and NAC goes as next smaller element. So please make sure whenever you're reading stack and queues, always go through next greater, like conceptually next greater element should be clear. I've seen people doing a lot of mistakes when they do stack. What they do is NGE. Okay, stack will run,
Yeah.
it'll pop it out. Greater element
Yeah.
one condition. They memorize and they go into the interview. And if I tweak the question of NGE, they are not able to solve it. So try to always have this stuff. So basically, in short, if I summarize this, whenever you need something as a data structure, wherever you want to figure out on the back, right, on the back or on the front, you need the smaller element right before that guy, or greater element right before that guy, in a like you don't want to spend a lot of time. You want that in big of one. You don't want to sort the array and then figure out. You want in big of one, someone tell me right before my index who was the small element, or right before my index who was the great element. That is when you should always think of something as monotonic stack. Okay, so And queues, I think queues is more or less. Any ideas about queues? What kind of problems?
Mm, specific problems, very less, but still
Okay.
the BFS one, the most real BFS one.
Okay. So I think probably that will be covered in graph. I will not prefer to
Yeah,
cover. I think queues in graphs is something which is very widely used, but still, I'll tell one use case of queue which you should always use. That is the LRU cache.
yeah,
It is very good. Please go through that problem again. I have made the video on that as well. If you want to understand the
I saw the
implementation,
video.
yeah, LRU cache is very good. And if you want to go harder, go to LFU cache, which is again a higher version of it. So yeah,
Same.
just go to LRU cache and LFU cache. And apart from that, I don't think Q has a lot of problems. Apart from I don't remember like rotten, or I can cover them in graphs.
For me, what helped to have a command over next greater element or next smaller element was
Mhm.
I studied next greater element. I had to look up the tutorial because it is not that great intuitive in the first one.
True.
So what I did was I tried my best to understand it. And next smaller element, I tried to solve it by myself without looking at the solution or something. Because
Mhm.
that made me realize that yes, I am good to go with the next greater element. Because if
Mhm.
you are able to visualize next greater element, then next smaller element, doing next smaller element is possible. Otherwise, it is very difficult.
True. So I think someone did mention trapping rainwater is a very good example of using monotonic stack, because
Yeah,
a lot of people you'll see in the internet they will just explain the prefix this two arrays wala stuff NG, but I think I'll highly recommend you. I have made this video in two parts. One part is the normal one, and the second part is using the monotonic stack. If you want to get your concepts clear, I think monotonic stack is very important. If you're getting a question in an interview from stacks, expect it to be from monotonic stack. So have your concepts clear out monotonic stack. Once you do 5 6 problems on monotonic stack, again you can just google on this problems related to monotonic stack and you'll get them. I think it's very good. Linked list, I think let's not discuss it, but because linked list is very obvious whenever they say
yeah,
uh, given an n linked list and you have to do so and so,
yeah,
so I think there's nothing to figure out in linked list. I feel in interviews there are very limited set of problems like 20 or 30. If you do them,
yeah.
you sail through the interviews. So again, someone again mentioned histogram is also a good problem. Yeah, these
That is
problems are
yes,
very
the
good.
thing.
These problems are very good. Okay, next one, bit manipulation. Again, I feel bit manipulation is something which is, does it come in interview? I don't think it comes. The only problem that is asked in interview from bit manipulation is power set. Have
Yeah,
you
the
encountered any
famous
other
one.
problem? It's like power set print all the possibilities of this particular stuff.
Still, when I found that the elegance that it has, yes, by having from 0 till the power 2 and minus 1, it finds out all of them. It made me feel very excited in the
Yeah,
first way.
I was also excited when I learned bit manipulation. So there is something as divide by two, okay? And
Yeah,
competitive programmers will never write divide by two. They'll always write
no,
right shift by
let's
one,
it, let's it.
right shift by one,
Let's it, let's
because
it. Divide by 1,
yes,
multiplied by 2.
yes, and competitive programmers will never write n modulo 2 equal to 0. They'll always write n and 1 because that
Yeah,
excites them. By the way, guys, are
yeah.
you enjoying this conversation? Let us know in the comments. Otherwise, we'll change something. But yeah, if you're enjoying it, just give us a thumbs up or something like that. We will be glad to see that. Anyways, recursion.
Hmm.
Hard. A beginner's nightmare, isn't it?
Yeah,
Okay,
but
if I ask you recursion,
ex
which is the
explore
most
all
common route?
possibilities.
Yes. Every time
Explore
you
all
see,
possibilities.
every time you see there's like out of all, which is the minimum.
Out
Or
of all. Yeah.
third of all, print this. Out of something, something like this. So that's when for me, I think recursion is something like whenever I see a question which says uh, try out all and give me the best. Try out this,
Yeah,
give me the best. Something which says me give me this, count the number of ways. Again, it's a
yeah.
very count number of ways.
Count the number.
But if I'm
What
talking
is
about,
the minimum one? What is the maximum one?
yes, I think that will go in DP. That will go in DP.
Yeah,
That will go in
yeah.
DP. But whenever it's like always or something like that, we introduce something like recursion. What do you think? Which is the most patterned question that is asked on recursion?
Never did really deep in the recursion because we are competitive programmers, so recursion questions are a little bit less. Only when the constraints are less than 20.
Yeah,
And
yes.
that happens very rarely.
That is actually a very good observation for everyone watching out there. Remember one thing: if the constraints are very minimal, like 14, 15, 16, 17, Recursion.
Yeah,
Mm, There's
less
no
than
other
pointless.
way. There's no other way. It has to be recursion. Very, very
Absolutely.
key important point. Whenever the constraints are very, very less, it has to be recursion. Or something, if I'm talking about just recursion, all subset problems. All subset problems. And there is a concept of pick and non-pick that you have to understand.
Yeah,
Once you understand the concept of pick and non-pick, again, you can watch my recursion playlist. You'll find the concept of pick and non-pick. I think someone commented Striver ways of counting. So yeah, you can definitely do that. And once you get the knack of pick and non-pick, na, like we
it
have to do a
solves numerous
recursion.
problems.
Yeah, it solves numerous, and I think you're not scared of recursion. And initially when you start, try to solve basic problems, but most of the common questions asked are on subsets, mostly subsets or subsequences. If you're
Yeah,
finding a term as subsequences or subsets or something like count number of ways or something
yeah,
like these which is revolving around all of these, it has to be recursion. And one more thing, constraints has to be very, 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 very less. Okay, cool. uh Bro, where can I get your playlist? No one knows me. Cool. Kidding, kidding. Backtracking, what do you think I never understood exactly what is backtracking, to be very honest. Have you understood what
I
is like?
understood when I started explaining it, to be
No,
honest.
no,
But
I know what is backtracking, that okay. And but
but I
for
got the
me,
intuition of it.
no, for me, recursion is backtrack. Like I don't, I write a line after recursion and I call it backtracking. That is bullshit. Like backtracking is what you're calling the recursion. After that, if you're applying some logic, that's basically you
Yeah,
backtrack and apply that logic. But that's recursion, man. Why are you calling it differently? Like
still,
that's for me.
yeah,
Like,
absolutely.
but for backtracking,
For
I
me,
think
it's how to say.
for you. Sorry, for you.
For me, it's like we have a path, we would
Mm-hmm.
visit that path, and
Mm-hmm.
in the next one, we can use the elements that is not there. Like suppose I have you, me, and our houses are all nearby. I
Mm-hmm.
take a path and I mark you visited. So in
Mm-hmm.
this path that I'm traveling, I can't take that I can't visit the same house again. But in the next one, I can visit your house. So I see a little bit, but still I'm not
it's
confident
still
enough with
it's
that
still
pattern.
recursion. It's still recursion. I've been
Yeah,
saying this, like I don't go on record and say it on playlist, but for me it's recursion. Come on, and I'm exploring all paths. It is still recursion. If I just introduce a visited array, it doesn't mean it's backtracking. But yeah, it can always be debated, isn't it? So someone is saying please close, please. थोड़ा noise आ गया, सिद्धार्थ, noise आ रहा है.
Please check again. I don't think
uh,
now there should be a noise. Please check again.
there is a bit of noise still.
Uh, there is a bit of noise. Just a
Yes.
second. No, it should be absolutely gone.
Perfect. It is gone now. Yeah. So basically, I'll say you can always name a lot of terms, but for me, it will always be recursion. Like papa papa ही होता है, तो वही चीज है.
Yeah,
For back
absolutely.
for backtracking, I think there are 4 5 questions which you should do. Something like an N queen, rat in a maze. There's Sudoku problem. I think if you do these three
Yeah,
problems, I
it's
think there are a
enough.
couple of more. And there are a couple of more. I forgot the question. Let me just. I wrote it down before this so that I can explain. Yeah, Sudoku solver, M coloring problem, rat in a maze, and there is something like yeah, I think 4 problems. N queen, Sudoku, M coloring, rat in a maze. I think if you do these 4 problems, you'll get a pattern. And most of in most of the interviews, they don't ask beyond this. Okay, they don't ask beyond this. Anyways, greedy algorithm. What do you think?
It can. I never proved a greedy algorithm, went with intuition in competitive programming. And the second one, if I'm able to have a formula which is working for my dry test cases, working for my dry run, it is greedy one. If I'm not able to figure out, it's not
Huh?
for me.
For me, greedy is like जो पहले दिमाग में आया. मतलब
Yeah,
as it,
absolutely.
like question, when I read the question, it's like ये तो ऐसे ही बनेगा. हाँ, यही greedy algorithm है, कोई अलग थोड़ी बनाऊंगा मैं algorithm.
Can I
मेरे
start taking the
दिमाग.
even one? Can I start taking the big one,
Yes,
small one, like
yes,
this?
yes. Can I take the smaller ones? Can I take the bigger ones? So I think if someone is saying me, is there a pattern? Is there a pattern of greedy? There can never be a pattern on greedy algorithm.
Never.
There can never be. If someone is coming across and saying this is the pattern of greedy, just tell him that you don't know programming, because greedy is something when you read the question and whatever your heart says. So see, job scheduling, these things are standard greedy problems. But when you go
Yeah,
into something like an uh, what to say, the online assessment, there will be questions where whenever your heart says something that go this way, it's
yeah,
more of like whenever you go to the streets and you are wanting to buy something, you always look for the ones with the cheaper cost or something like that, right? And or if you're buying a flight ticket, you're always looking for the cheaper cost, right? So that's greedy in nature. So I think greedy is something which will come to you normally. But just to make sure, I always tell this whenever I teach, if you're applying greedy algorithm, always make sure you try your algorithm on 10 to 15 test cases. Because a lot of time what happens is that algorithm might not work. You might think, because what happens is the the problems that come up in online assessment, they'll always give you very very easy test cases, which will
yeah.
always run on the algorithm that comes to your brain first. And what happens is a lot of people code it and submit it, and then they get a wrong answer. So I always recommend, instead of running your algorithm on those given test cases, make 10
Yeah.
to 15 test cases of yourself, run it in and check, and you might find that your algorithm is not running, right? So always be very very careful. Okay, cool. So for greedy, there is like job
I got
scheduling.
many wrong answers because of this.
Yes,
I used
that
to
is,
have a dry run on the sample test case, and
yeah,
the sample
it's
test
very
case
bad.
mostly are the very easy ones,
True,
and they
true, true,
would
true,
eventually make us fail.
true. So on greedy, there will be a lot of like, if you, Dijkstra is a kind of greedy algorithm, because if you use priority queue, so there's a lot of greedy algorithms that
Yeah.
we can classify. But let's come back to the next one, which is trees. Oh, interesting topic. What's your take on trees? I know for a computer programmer, binary trees and binary search trees are not trees, but for interview
Yeah.
specific, trees is binary tree and binary search tree. Let's not talk about the NRE trees, because I feel they are not asked in interviews. I haven't seen like uh, in Google and Amazon and Microsoft, all these top product, even in startups, they don't ask something else which is related to NRE trees. But yeah, when you go to online assessment, they might ask you questions which are related to NRE trees. But then binary trees and binary search trees are the core concept of interviews. So what do you think about them? How do you prepare them?
Mm, Mostly in the interview problems, trees thing is given, and in online assessment or other things, I go move forward with the STL thing.
Huh, interesting. So for me, what I did was, I'll tell you, I'll be very honest. So I was the guy, like I was similar to you during my age. So I used to do this a lot of computer programming. So when I came
Mm,
across this binary tree, I said, oh, what is this binary tree pointer and all? So I actually went into one interview and I solved the binary tree problem using NRE tree. And then I got to know there is
okay.
something as a binary trees as well. Then I came back and studied, and then I understood,
Mm,
if you're going in an interview, it's always the generic question in trees. You don't have to prepare out of the box. There are some standard questions. Just go through
yeah.
them, and you will be more than enough. Like, they might ask you to do pre-order traversal, in-order traversal, uh, in this complexity, in that complexity, without using space, using stack, using this, using that, in Morris traversal. So you have to be very careful if you're reading trees. You can't be like, this is tough. Like, I've seen people saying Morris traversal is very tough, right? So they say Morris traversal is very tough. I am sure you don't know more, like, sorry to judge, but do you know Morris traversal?
No, absolutely
I,
not.
I I was I was taking it right, because I also, as a computer programmer, never knew what is a Morris traversal. And when you read it, it's actually very good. It's something like they apply threading on it. And try to read, like, I have a video on it. If you have time, just go back after
Yeah,
this
sure.
class.
I have a lot
Uh,
of time to watch your videos.
so go back and watch it. I felt very good when I did not know it. I learned it when I was making the tree series videos, not before that. So when I made this tree series 55 videos, I learned it. So it was wonderful. Like, you'll see the back threading working. It was something you'll be like, "ये किसने बना दिया, कैसे बना दिया इस बंदे ने, बनाया कैसे बंदे ने इस एल्गोरिथम
Okay.
को?" मतलब कुछ कुछ एल्गोरिथम्स होते हैं ना, देख के लगता है भाई तूने बनाया कैसे, बता। और कुछ कुछ होते हैं, हाँ ठीक है,
Mm.
ये तो इंट्यूटिव है। बट आई थिंक Morris traversal is one of the algorithms which whoever has made it have, I'm a huge admirer of it, because it is something out of the world. So check this out, Morris traversal.
For me,
Okay,
it's KMP one.
KMP is good, but I'll still say go and check out Morris traversal, and he'll come back and text me on WhatsApp, भैया सही में बहुत तगड़ा algorithm है।
Sure,
it,
I
it
will.
is, by the way, people, Morris traversal is pretty easy, but I can bet you can't think on yourself. You might think it is easy, mostly because you've seen a video or you have learned the algorithm. But I can bet on this that no one can come up with that algorithm over here as of now. You might, if you're extraordinary, it's very tough to think on that threaded concept. But anyways, for trees again, I think there is no pattern for trees. For trees, it will always be standard interview questions if you're going to interviews, and try to figure out all the standard interview questions. They're like 60, 70. You'll find 55.
Everyone.
Yeah, you'll find 55 of them in my playlist. I've made a playlist, some dedicated one. You can check them out
Okay.
as well. Okay, so the next one is graphs. Interesting. I'm making a whole lot, like 45 videos on this, by the way. So, what do you think about graphs? A lot of
In
patterns.
graphs, what I did was I have listed all of them like shortest path algorithm. If
Mhm.
it has no weights, I would move forward and use BFS. If it has some weights or positive weights, I would move forward with Dijkstra. If it has
Mhm.
negatives, no, I kind of checklist kind of thing. Yeah, this is
Mhm.
gonna work, this is gonna work, or this is not gonna work. Like
Okay.
many a times, the intuition for that DFS one is not that great. Like for many a times, BFS question is also not that great intuitive. So I have
Mhm.
a kind of checklist to battle this graph problems.
हाँ, तो एक मैं बताता हूँ, like for me graph was, when I started with graph I could never understood how DFS worked because I was very bad at recursion. वो DFS में समझ नहीं आता ना, पहले इस नेबर पे गया, फिर आएगा दूसरे नेबर पे जाएगा, फिर आएगा दूसरे नेबर पे जाएगा. एंड आई स्टिल रिमेंबर सेकंड ईयर में ना मैं कॉपी में उसको पूरा प्ले ड्राई रन कर करके समझता था. मुझे कभी नहीं समझ में आया था सेकंड ईयर में. आई थिंक इन द एंड ऑफ द सेकंड ईयर आई स्टार्टेड अंडरस्टैंडिंग. ठीक है, एक नेबर पे जा रहा है, पूरा विजिट करके वापस आकर दूसरे नेबर पे जा रहा है, तो थोड़ा टफ होता है. बट आई थिंक for graph, most of the questions on graphs will be of two kinds. One is the matrix kind of problems, which is more or less wo wala problems the rotten oranges. Then there are
Yeah,
problems which is like number of
multi-source
islands.
BFS.
Yeah, multi-source
Yeah,
BFS, rotten oranges. Uh, there is something like number of islands. Then there is something like a lot of problems. I'll be covering them in my upcoming playlist. There's a bunch of problems I figured out, and multi-source BFS is one of the most frequently asked question. So you'll always find questions like कि there's given a n cross m matrix, ये कुछ ऐसा ऐसा है, कितना टाइम लगेगा, या फिर एंड रिजल्ट क्या होगा. मतलब इट विल ऑलवेज बी लाइक कि स्टार्टिंग के ये बंदे ये कुछ ना कुछ कर रहे होंगे, एंड एंड में क्या मिलेगा या फिर कितना टाइम लगेगा. If you find a question related to that, that is always related to multi-source BFS. ठीक है, so make sure you watch that out. Multi-source BFS. There is also a single source BFS, which is moreover like कि एक point से शुरू कर रहा है, बाकी सारे point
yeah.
पे या minimum time कितना लग सकता है. That is a
Most of the
single source
time,
BFS.
that is the
Yeah,
thing.
most of the time. So there is one of BFS questions. There is one of the BFS questions. ठीक है. Uh, and the other format that I found is that's this shortest path algorithm. So BFS is optimized using Dijkstra. So if you find any shortest path question, saying कि यहाँ से शुरू हो रहा है, सोर्स ये डेस्टिनेशन है, बीच में कुछ तीर तीर करेंगे. बट अगर ऐसा
Hmm.
क्वेश्चन दिख रहा है तो फिर डायरेक्टर दिमाग में आना चाहिए कि सोर्स डेस्टिनेशन जहां आ रहा है. Whenever there is a question which involves source and destination, you should think of Dijkstra, right? And
Yeah.
going forward, there is one other algorithm which is this disjoint set union, which is disjoint set union with I forgot the name, with rank.
Grouping of
No,
elements
no, no,
using rank.
just a minute. I forgot the algorithm. Disjoint set union with uh, एक तो है रैंक और पाथ कंप्रेशन, और एक मैं एक्चुअली रैंक और पाथ कंप्रेशन बाय साइज, बाय वन बाय साइज एंड वन बाय रैंक एंड पाथ कंप्रेशन.
Yeah.
सो देयर इज
Yeah,
कपल ऑफ
absolutely.
डिसजॉइंट सेट यूनियन. एक आप रैंक से करते हो, एक आप साइज से करते हो, दोनों को याद रखना. बट फॉर्मेट क्या है डिसजॉइंट सेट यूनियन का? मोस्टली you will have to figure out this by your own. Try to do more and more problems. I'll give more and more problems in the upcoming playlist. Disjoint set union is more over like जब आपको पता करना है कि दो बंदे हैं, क्या दो बंदे एक एक जगह को बिलोंग करते हैं. So
Hmm.
whenever you are solving a problem and you feel like that दो बंदे मुझे जानना है, शॉर्टेस्ट वे में जानना है कि दो बंदे एक बंदे को बिलोंग करते हैं कि नहीं. होता है ना,
Hmm.
ग्राफ मल्टीपल कंपोनेंट्स पे टूटा हुआ है.
Hmm. Hmm, hmm,
And I need to figure out, are they belonging to the same component or not. So whenever there is something like this, you will always feel like, okay, this is where I can apply disjoint set union. ठीक है, समझ में आ गया? तो you can always say this is a case. और क्या डिसजॉइंट सेट यूनियन के बाद और कुछ आता है ग्राफ्स में? बाकी उतने पूछे नहीं जाते,
hmm.
ये तीन पूछे
फॉर
जाते हैं.
मी डिसजॉइंट सेट और एक कंफर्मेशन होता है कि वी कैन स्टार्ट ऑफ फ्रॉम द बिट्स. Like from the cells of a body, we can start off with the nodes of a graph. If we can start off in that manner, we can use DSU. And that gives a
Okay.
proper confirmation
Okay.
that yes, DSU, we can proceed with that.
ओके ओके सो इसको छोड़ के और भी है एमएसटी भी है मिनिमम स्पैनिंग ट्री वो भी कर सकते हो
Yeah, yeah,
so there
sure.
is something like uh, minimum spanning tree as well which that is not asked most of the graph questions will be always on bfs and it will be always on the other thing which I said disjoint set and extra so ये तीन पे ही मोस्टली इंटरव्यूज पे फोकस होता है तो ट्राई करो ये तीनों का कॉन्सेप्ट तगड़ा हो ओके एंड नेक्स्ट इज डायनामिक प्रोग्रामिंग
The famous one.
the famous one. I think there is like a lot of patterns on this, and
Yeah.
I've made these patterns. पहला pattern तो 1D है, 1D DP, and
Hmm.
there is like 2D DP. There is after that DP on subsequences. Then there is like a lot of things. I think we will not discuss this, but dynamic programming just go to the playlist. You'll find all the patterns arranged probably,
Yeah.
and you can check it out. Yeah. What's the next
Okay,
one?
sure. Try.
Tries. What do you think about this?
When I want to search in a string, the substrings, I want to search parts from the string. I can start off using try. Like strings or a pattern kind of
अरे अरे
thing, I
भूल गए
want to search in
अरे
it.
एक सेकंड एक चीज भूल गया टोपोलॉजिकल सॉर्ट हाँ टोपोलॉजिकल सॉर्ट इन ग्राफ इज इंपॉर्टेंट डू द कोर्स शेड्यूल प्रॉब्लम एक प्रॉब्लम टोपोलॉजिकल सॉर्ट का करो जिंदगी भर टोपोलॉजिकल सॉर्ट नहीं भूलोगे कोर्स शेड्यूल ऑन लीड कोड कोर्स शेड्यूल इन लीड कोड ओके दैट इज समथिंग व्हिच यू कैन
Mm,
ऑलवेज डू
One problem from my side also, alien
व्हिच वन
dictionary,
ओके
which is using topological sort on the characters. It's a beautiful problem. Like it is, we are given a new kind of dictionary and we need to find the ordering. And yes, if we know that this problem needs to be solved using topological sorting, it seems easy. But when you come across in the first hand where you don't have the background, yes, this problem belongs from this, it seems very hard, even if you know.
Okay. So Alien Dictionary and Course Schedule are the two main. Okay, I'll also check this Alien Dictionary. I haven't checked it out. Cool, I'll check this out. Okay. Next one is tries. What do you think about tries?
Searching in a pattern, substring searching,
Mhm. Substring
I
searching.
can say.
I think tries problem are more or less XOR problems. Whenever you find
Yeah,
maximum XOR, I think most of the problems of tries are related to maximum XOR. I think there are
got problems.
there are 4 or 5 problems in tries. Apart from that, the interviewer will never ask you anything. And there is another one, which is the string wala stuff, which is the
Yeah,
longest prefix or something like that, or suffix. They either ask you the longest prefix, which is present in all the strings, or longest suffix, which is present in all the strings. So there is this ये दो वाले चीजें बहुत ज्यादा रहते हैं एक तो स्ट्रिंग का सिमिलैरिटी और एक जॉर आई थिंक
Zor.
if you add them up there will be like 4 or 5 problems if you do them that's more than enough for interviews you don't need to do it again इसका भी मैंने सारे एडवांस टॉपिक का प्लेलिस्ट बनाया इजी वाले का नहीं बनाया ये लेफ्ट वाले का सारा प्लेलिस्ट बनाना है मेरे को पता है और स्ट्रिंग नहीं बनाया
हाँ,
कोई नहीं ग्राफ के बाद
जरूरी है.
बाइनरी सच ग्राफ के बाद बाइनरी सच बनाएंगे बाइनरी सच तगड़ा बनाएंगे 35-40 प्रॉब्लम्स का बनाएंगे cool. I think the next one is strings. I think over here also, I think there's nothing to discuss because most of it will be like pattern matching problems. Whenever they say ये pattern कितना बार exist करता है या फिर ये there are like 4 or 5 algorithms in strings. Just go through that Z algorithm, KMP, Ravencap, and there's a couple of more. Just go through those algorithms. I think more than that, people do not ask strings. And एक और मजेदार बोलता हूँ मैं बात करता हूँ ना अपने कलीग से मैं पूछता हूँ तुम लोग स्ट्रिंग एल्गोरिथम्स इंटरव्यूज में पूछते हो बोलते हैं हमें हम लोग खुद ही कॉन्फिडेंट नहीं है तो हम लोग क्या पूछेंगे तो a lot of interviews tend to skip it a lot of interviews will skip it unless until you'll find an interviewer who is a very good competitive programmer uh, you'll find most of the people skipping string stuff so you don't have to be that much okay you don't have to be that much into it स्ट्रिंग ऊपर से जान लो मोस्ट ऑफ द इंटरव्यूज टेंड टू स्किप इट एंड ये मैं ऑन नोट बता रहा हूँ मतलब जब भी बात करता हूँ बोलते कि अपने को जो नहीं आता मैं नहीं चाहता कि पूछूं एंड एज एन इंटरव्यू मेरा भी यही पॉइंट ऑफ व्यू है अगर मैं खुद ही वो प्रॉब्लम नहीं सॉल्व कर पाता हूँ मैं कैसे सामने वालों को एक्सपेक्ट कर रहा हूँ सॉल्व करने के लिए उसी कंपनी के लिए सो इंस्टेड ऑफ दैट डोंट आस्क इट राइट cool I think 45 minutes we discussed a bunch of things uh, I,
True, damn true.
guys
Okay,
did you enjoy
okay,
this
okay.
45 minutes session नाक नोज पे ना कुछ तो हुआ है रेड हो गया नोज मेरा
नया इन्वायरमेंट है ना।
अरे नहीं, यहाँ पे एक्चुअली सेशन लेता हूँ ना तो पूरा ये रिंग लाइट गिरता है, तो वो मुंह पे ना
हम्म।
चिड़चिड़ होने लगता है। बिकॉज बहुत गर्मी है इधर, तो इधर फैन नहीं होता, पता है ऊपर अगर मैं दिखाऊं, यहाँ पे ऊपर ही रहती है, फैन नहीं है ऊपर, देयर इज नो फैन लिटरली, एंड इफ यू स्टैंड योर हेड्स गोना टच होता है। इट्स काइंड ऑफ वियर्ड यहाँ पे, क्योंकि यहाँ पे पूरे साल में आपके 15-20 दिन रहते हैं जहाँ पे आपका टेम्परेचर इज लाइक मोर और लाइक 25 के ऊपर जाता है। एक महीना एट मैक्स रहता है, बाकी सब टाइम अंडर 15 अंडर 16 रहता है।
अरे वाह, बहुत बढ़िया तब तो। Okay, so we would be starting off with the Ask Me Anything session. We have a lot of questions. Still,
ओके,
start depositing your questions. So let us start off with the very first question, which is this one.
someone is commenting there is no fans because all of us are here. कुछ भी।
Yeah. Okay, so then the problem. Okay, just let me see. This one is long enough. Let us skip this one. Just a sec. Yeah. So how will we know that we have done enough questions on a particular data structure and algorithm, and we should move to other data structure algorithm?
I
What do you
feel
think?
honestly, there will never be a day when you'll always feel. I still now on, there will be a lot of times you will be like you'll not be able to solve it, and it is absolutely okay. We're human beings. It's not necessary that if you're doing dynamic programming you should be able to solve every DP problem that comes up in the future. So what I recommend is whatever list you're finding on the internet, it be it the Strava SD sheet, be it any sheet, be it any playlist, be it mine, be it anyone else's, if you are covering for a topic all the required patterns, very important, whenever you are learning a DES data structure, always try to cover the data structure in terms of patterns. Like if you're learning DP, try to cover it in terms of patterns. If you're learning graphs,
Okay.
BFS, shortest path, try to cover these problems instead of covering, okay, I want to do 100 problems. There's going to be no use of that. Instead of that, pick up the, like if graph is divided into DFS, BFS, shortest path, etc. From DFS I'll do two problems, three problems. From BFS I'll do three, four problems. From this I'll do three, four problems, so that I have an idea about that. And after that, I'll keep on giving contest every now and then. And in contest, if I'm not able to solve, I'll understand, okay, I'm still not good enough. Probably I'll need to do a couple of more. And this is how you eventually manage to grow. Okay.
Okay. Let's move forward. Okay, so how to get shortlisted for companies which come for internship? I have no previous internship and only one good project.
If I also did not have any internship, and uh, see, doing an internship is not mandatory. When I started my first job was, if you guys don't know, I started with Direct Eye as a first full time job. So when I applied at Direct Eye, my resume did not have any internship, any software engineering internship. I just had one minor project, which was again picked up from Udemy. I did some minor changes to it. So it's not necessary that you have an internship, but the thing is you need to understand, if you're lagging somewhere you need to make it up on the other fronts. It's very important. So for an example, let me say you, if you don't have an internship, okay, so apparently internships are to be done in the summer vacations. So summer vacations are of 2 months. So I want to see, okay, if this guy did not do an internship in those 2 months, what did he do? Right? So maybe you can utilize that 2 months to make a very good project. And you can tell the interviewer that, okay, I did not get an internship because I belong to a tier 3 college, or there are no companies visiting my college, or I was from this branch, I was rejected, or I did not get a lot of opportunities. It can be anything. Okay. So you need to tell them, and you need to tell them, then you can defend them. I did not get an internship, but I did not sit back. I went back and I learned this tech, and I made this wonderful project. You can definitely check it out. So I have proper dev experience, or proper Android experience, or proper whatsoever experience. But the thing is, you can't be like, I don't have an internship and I don't have a project. That can't be the case. If you're not getting an internship, you have to make sure those 2 months or those free time that you're getting by not doing an internship, you make it count by doing something which you can tell the interviewer, dude, listen, I did not get an internship, but I am hardworking. This is why I made it. Got it?
True. So, here's Trevor. How do we identify the recurrence, if it all exists, for a problem? And how do we identify the best algorithm for a problem?
Wasn't the session all about that?
Yeah, I think this is already covered. Let's move on to the
Yes.
next problem. So, so that is this has also been explained. How to decide whether a given problem will be solved using DP or greedy, because both are optimization problems. How to think and how to approach these problems.
Hmm. So I'll say, if you are seeing how to for DP, I'll say try to cover up all the patterns. Once you cover up all the patterns, you'll find you'll find a generic way of expressing the, like, understanding the DP problems, that this is a DP problem. So the best way to do is, again, as I said, whenever you're solving a greedy problem, if you think it's a greedy algorithm, try to do it with 10 to 15 test cases, or you will see it is failing. The moment the greedy fails, and the moment you see there is an option of trying always and picking something from it, then you can move to DP. And the other thing is constraints. If you see the constraints are something which can relate to a 2D, mostly the problems are 2D, like 10 to the power cube, then you
Yeah.
can just omit greedy. So mostly I have seen the problems are of 2D, and the constraints are of 10 to the power cube. You get an idea that, okay, this
Yeah.
is the dynamic programming.
Okay. So let us move to the next problem. What is what can I do if my criteria is not fulfilling for on-campus placement? Required is 60% throughout, but I'm having
It,
only 52%. Same case
it
with
is
me.
Yeah, it is a bit tough. If you are just starting off now and your percentage is under 60, I think a lot of companies will not consider you. But then startups don't care about that. So just make sure your profile should have good enough projects, because startups will not look at CP profiles. And again, you can track Google as well. Google doesn't care about if you have backlogs, if you have a lot of these stuffs. Google never will care about that. Even in my team, I have a lot of people who have not done graduation. So it's absolutely okay. Google doesn't care about these things. If you have prior experience, prior knowledge, prior understanding of algorithms, it is okay. But all the other companies like startups, they will require some dev experience. So I'll always recommend go and do some wonderful projects, and probably do some freelancing works, build that portfolio, so that you can tell them, okay, fine, it was once in a while that I did not study. Back now I've studied, so I'm perfectly okay. Anyway, so that I'll take a couple of more questions, because my
Okay.
my vocal cords will be gone.
Yeah, absolutely not an issue. Okay, so I have a hard time understanding DP. I generally solve lead code mediums and have a good grip on data structures. How much number of recursion and DP question should I solve to gain confidence in it? Can you
Again,
please?
it's being repetitive. You just pick up, if you're doing DP, pick up the patterns. Don't do DP blindly. If you do DP blindly, you'll always struggle. DP is all about patterns of subsequences, patterns of 2D, patterns of partition DP, patterns of string DP, patterns of stock and span problems. So try to do it in pattern wise. I'll just share this stuff. Try to do these problems once. There are like 57 problems that I have made. I'll share the link. The link is over there. So try to do
Mhm.
these 57 problems. 57 problems is a lot. Once you've completed these, you'll have a lot more experience, a lot more knowledge about DP, and then you'll not be asking these questions, trust me. So don't run behind how much, instead of run behind covering the concepts. That should be the main stuff. Anyways, guys, the last question, because trust me, I'm tired after having an 8-hour office and a 1 hour session. I need to again record the graph videos as well after a hour break. I'll take the last
Okay,
question.
so last question. You are tired from office. You have been working for Google. So you are working
Yes.
for Google. So let's take a question related to that.
Okay. Okay. How
How
did
did
you
you
get a job
get
in
a
Google?
job in Google? Which
Okay.
skills is required for getting a job in Google? Is your interview round was tough?
No, the interview round was not tough. Are, how did you get a job in Google? Uh, uh, अरे वो ऐड है ना रुको. If you want to get a job in Google, go to your browser, type careers.google.com, then go to the search bar, type software engineer. You'll find a link right at the top. Click on that. There's a apply button. Go and apply. So that is something which you can do. The other thing you can do is, if your profile is good enough, you can reach out to employers like us or someone who's working in Google and ask them for a referral. and if they find you a good fit, they will definitely refer for you, and then you can go and apply with the referral. Or the third way, which happened with me, was there was a recruiter who bumped into my LinkedIn. She said that I'm seeing that you interviewed for Google back in COVID and you were not reached out. So I said yes, I did interview during the COVID era when the hiring was freezed. So they picked up my resume from there and they gave me a call, and that is when the process started. And after that, the process went on. There were like 5 rounds and I made it. Was the interview tough? It isn't tough. If you're a competitive programmer, you'll find it easy. Even if you're a very good lead code solver, it won't be that tough. But yeah, if you're not into DS algo, it will be tough, because for Google, the entry level roles, or even if you go to L4 or L5, whichever roles you're talking about, will always have a DS algo round. So your DS algo has to be good enough. With skills, DS algo is mandatory. Even if you don't have projects, it works. Even if you don't have a CGP, it works. Even if you don't know anything, it works. As long as you know DS algo, at least for an entry level engineer, they will just test you on DS algo. And if you're very good on DS algo, what Google assumes is this guy is good at DS algo. He's gonna grab up anything. So that's what they usually do. Okay, cool. I think that is it for today, guys. I hope you enjoyed the session, and there's a link on the description. I was set to inform you about. So there is a link where you'll find all the sessions, all the upcoming sessions, all the knowledgeable sessions that are going to be taken. There's a link in the description. You'll find it out. And yes, Amazon is hiring by Jobathon. Make sure you register for that. It's on 5th of July, February 5th of August, by the way. And I'll be solving all the problems right after the Jobathon of Amazon at this channel only. Like बहुत कम दिख रहे हैं, इतना ज़्यादा watching है. Like is very very less. I'm very unsatisfied, but कोई नहीं. Thank you guys for
We
joining
would
in.
have the like eventually.
Uh, Thank you Siddharth for hosting me. It was wonderful.
The
अगली
pleasure
बार
was all mine.
host मैं बन गया, अब तू host कर ले, end कर ले.
Sure.